Hello, my name is Michael Lugring. I'm working in partnership with Andrew Leonard, and our team program and focus is on something we're calling urban mobile sensors. Urban mobile sensors leverages the available technology of bike-mounted mini sensors to remap the urban environment. By that we mean that through using custom mini sensors that are widely available and a rapidly growing concept of bike sharing within urban spaces throughout the United States and the world, we believe we're able to leverage basic technology associated with crowdsourcing to really understand or imagine a new way of thinking about how to depict, interact with, and develop urban space. We hope that you're familiar with, but if not, this is an image of standard bike sharing operation in Boston known as Hubway, but takes on many forms and names around the world. Using this in conjunction with its wide and vast array of bike stations around Boston, we believe that with over 100 stations in the greater Boston area and more than 1,000 different target locations and bikes moving within the city, we're really able to leverage this understanding of crowdsourcing as a way to take advantage of data not typically known or seen. The existing mapping that we have in a space like Boston is pretty limited in its function and its ability to really explain urban space and the experience and the function you might get from it. But yet, when you think about how you interact with an urban space, especially on a bike and in transportation, you notice that things like pavement quality, smog, air pollution, congestion, traffic, these are some of the really basic but really important things that, as you see from this map, are lacking in our current understanding and ability to map. So what I'd like to do is bring on Andrew Leonard to talk more about how coverage works and how the technology is able to influence this.
Current mapping techniques are very limited as far as the interface with the urban environment. Currently, for instance, road quality is measured using the PCI scale. This is a 1 to 10 scale that is assigned by a person on the quality of the road. Additionally, air quality is mapped in Boston, as you can see here, using 5 limited stations. This gives a very broad overview of the air quality of the urban environment, which is subject to great fluctuation and kind of like microzones when it comes to these environments. As you can see in the overlay, there's a huge potential to collect vast quantities of data by linking to the Hubway bike share system. This is a 1.5 mile radius around each of the bike share systems, so you can see that by mobilizing sensors, we're able to collect vast amounts of information. Our current sensors are based on discrete sensors that we're able to change and use in different ways. There are air quality sensors. We have 4 sensors in here. This way you're able to map 4 different air contaminants. There are proximity sensors allowing you to understand how much room a cyclist have. This also gives you information on general congestion of a road. And the accelerometer, this is used to measure the microtopography of the road. This is a kind of a major important thing in all cities, as there are huge quantities of pavement throughout the city. And using the PCI is just a qualitative way of understanding the road quality, whereas this will actually allow us to collect quantitative data on this. As you can see here, we're linking this sensor with the Hubway bike share. The sensor is easily installed. You simply remove this from the front, 3 screws and 2 wires, and you can transition any Hubway bike into a mobile sensor. Not only is that easily transitionable, but the sensors themselves are fully customizable. You're able to swap out different sensors, thereby allowing you to either customize the sensor itself for the individual client, or by mixing sensors amongst different bikes, you're able to get even a larger variety of data. We're also developing bike-mounted sensor mounts for the iPhone. We want to leverage or not just the iPhone, but smartphones in general. We want to leverage the sensors inherent in these phones with accelerometers and GPS in them already. Everybody's already carrying these, so we want to further our crowdsourcing by linking with the general cycle population in this way. And on that, I'm going to have Michael come back in and talk a little bit about users.
So we view the function of this in three basic target audiences. Your day-to-day user and commuter needs to understand everything from how I get to work more safely in a more healthy environment in a similar rapid pace as I would any other day. Your traffic engineer and city planner needs very, very high quality and quantity levels of information based on everything from the degradation of pavement to different social classes in their relationship to the quality of air. And also we have people like researchers who are working with children's health quality in different advocacy groups, also needing some of the information provided with sensors that we have been developing for things like air quality and its relationship with asthma. And so what I'd like to do is kind of run you through, on a day-to-day basis for a daily commute, a person may wake up and decide on a hot summer day that's smoggy, there's lots of traffic, that they need to find the most efficient way to avoid flaring up their asthma, to developing safe habits as far as bike congestion and traffic, the proximity between cars and congestion. And so they can turn to our system. They can open their iPhone, they can open their smartphone, they can hop on their bike, and they can arrive efficiently, safely, and in a helpful manner to their job. And as you can see in this image, simple bike-mounted technology in relationship to your smartphone is enabling you to do that and making more informed, educated decisions about how you commute. At the same time, or in that broad scale, you have health researchers who at this point in time have very basic and very broad coverages of data. It doesn't really allow them to pinpoint corners, avenues, blocks, subsections of cities that are actually being affected in a much more finite and discrete manner. But what we've developed, and you'll see this overlay of a Google Earth image with our technology being mapped in South Boston, is that we can actually pinpoint corners, blocks, sections of neighborhoods and cities that are being directly affected by pollution, discrete traffic, and other public health and safety issues. So the data is a spectrum. Through one single input, we're actually able to take on data that can be kind of divided and diffused into a bunch of different user groups who would never otherwise need to speak to each other, but can be done so in a very, very efficient manner this way. So at this point, it's best to now transition back to Andrew to close out to talk about funding, production, and our potential outlook for the future of this project.
So as we launch urban mobile sensors into a full business, we think with a very small startup funding, we can be cash flow positive within the next 2 to 3 years. There's very low overhead. All we need to do is create the sensors, and there are networks out there that we're already working with in order to launch this. Points of entry include the Office of New Urban Mechanics. This is embedded in the city of Boston as a way to further technology to benefit the everyday Bostonian. The Department of Innovation and Technology, generally just speaking, a broad range department based on innovation. And then the mayor's office. The mayor's office has been pushing for a long time to get the creative class to come to Boston and to stay here. And as we all know, creating a healthier urban environment really locks down that demographic. As we enter the market, we're beginning with the New Urban Mechanics. They are kind of our center point to meet and launch into these different areas. We've already been working with Boston Bikes and Hubway in order to get these sensor prototypes out in order to test and prototype them. From Hubway, we're looking to work our way up the chain to Alta, into markets like Bixby in Montreal, Capital Share in Washington, City Bike New York City. From the New Urban Mechanics, we've also been able to meet the Office of Information Technology, the Metropolitan Area Planning Commission. These are kind of all areas that are already very interested in this information. From here, we're also branching out into research partners, as well as government agencies, Department of Environmental Protection, and such. And just very quickly to show how the data user network can function, by using the three sensors that we've already talked about for road quality, proximity, and air quality, you can see that these different types of information allow us to feed data into a large variety of people. We're able to start small, collect vast quantities of data, and expand out into this larger network. Then, through the dissemination, use, and understanding of this data, these different agencies can work back and forth with each other in order to really affect policy and change the way that the urban environment works. We see this as a big potential. Just in March, the EPA released a draft document basically saying that they've come to realize that these very expensive stationary air quality sensors are no longer viable, economically viable, and that they're seeing these, mini sensors are kind of the wave of the future. This bodes well for us as they're looking just now for an idea, we're already developing a solution. We've looked a little bit into competition, things such as the Air Quality Egg, Common Sense Research Program. Though these are very good and have really good potential, things like the Air Quality Egg, it requires a person to really make the active decision to purchase this, mount it outside of your house, hook it up to your home computer system, and update information. Whereas with urban mobile sensors, we're able to passively collect information by linking with the Hubway bike share. Additionally, Polymap's program out of the Bay Area in California, they're using, it's a really nice visualization technique. Unfortunately, it still uses the qualitative PCI score. It doesn't actually collect any new data on urban road qualities. So a little bit about us. My name's Andrew Leonard. I've been working with Michael Lugring. We really see our role in urban mobile sensors and urban mobile sensors' role in the urban environment through the lens of landscape architects and urban designers. We really approach a system way of thinking. We have enough knowledge in very diverse areas in order to build these prototypes, understand the issues, come up with new solutions for them, and then link to partners in urban planning, in the healthcare system, in order to really push this forward. And as we move forward, we're currently speaking with different people in order to really hone in and develop the sensor network. We're currently in talks trying to find a sensor partner to do a venture with them in order to refine the sensors. We're currently looking for an engineer and planning firm to embed with, and we have a couple that we're already speaking with. Application development is something that once we are able to collect enough data, we are going to be looking for someone in order to really refine both the app and the digital mapping. And we're also looking at sensor diversification. There are other people that we've been speaking with who are doing similar urban mapping type things using mini sensors. So over the coming months, we're going to be setting up some meetings and trying to figure out how we can work together in order to get even better data sets. So we really see this as an opportunity to change the way that we understand the urban environment. With increases in densification and urban population, the urban environment plays a huge impact on the health and well-being of its citizens. But currently, most of the urban environmental conditions that really have a day-to-day effect on people are currently unmapped. We see the potential of urban mobile sensors as being able to change this. We can start on the small scales we've discussed today, but as you can see in this map, we can launch in anywhere that has a bike share network or even just cycles. That way, by proliferating these sensors, we can remap the urban environment of the entire world. Thank you.